All right, welcome back again to Number Sense Academy, and today we're going to look at quadratic equations in vertex form. So, quadratic equations, let's write that out. Quadratic equations in vertex form. So, what exactly is vertex form? So, before we get to that, let's look at the other two ways that we can write out quadratic equations. And the first way is what we call standard form. We have factored form, and then we have vertex form. Okay, so standard form is just y is equal to ax squared plus bx plus c. Factored form, we have y is equal to a times x minus r times x minus s. And then in vertex form, we have y is equal to a times x minus h squared plus k. Now, each of these have their own, advantages, so to speak. They are interchangeable, so you could work your way from standard form to factored form to vertex form, or from standard form to vertex form, or from vertex form to factored form. Um, and then you could use the advantage that you get from each to be able to solve questions, answer questions, do analytics, make decisions, so forth. So in standard form, really the information that we get right away, we know that it's quadratic because of this 2 that appears here. And we can readily find the y-intercept. And we can tell whether we have some sort of stretch or compression. But before you even get into that, you really need to be really attentive to the full equation to see if you have a stretch or a compression from looking at A. But the sign in front will tell us if we have a upward or opens upwards or downward. So the direction of the opening. Okay, so just by having this equation in this form, we could really pull aside those two things. When we have the equation in factored form, again, we have A. So again, we could tell if it's, or we could tell the direction of the opening. Uh, we could also, A is also a factor, and it tells us how the graph is either stretched or compressed. We have the zeros, so S and R are zeros, so we could get the roots of the equation. We could calculate the vertex, all right? And if we can calculate the vertex, we could find the equation of the axis of symmetry. Okay? Now in vertex form, we have our compression, and I should have called this before, compression slash stretch factor. So is it pressed against the x-axis or pressed against the y-axis? H and K tells us the vertex, and we'll get into this a bit more. We also know the y-intercept. No, sorry, that's not right. It's only the y-intercept if there's no translation. It's not the y-intercept, that is my fault. That is based on A, or sort of the sign in front of A, right? We can tell the direction of opening. And from the direction of opening, we can tell if y is a maximum or minimum. That's what that can tell us. And we could also, and then based on the, if I go back to factored form, we could also tell if we have a max or min. based on the negative sign as well. So those things are, you could readily see what's available in each form. But in this example, or in this video, we're focusing strictly on vertex form. So let's dive into this a little bit more. So vertex form, we know that we have y is equal to a times x minus h squared plus k. So the vertex of the equation, or if I was to graph it, I would see the vertex. It's actually a coordinate value. So we have x and y, and x and y are equal to h and k. Okay, so one thing I want you to notice is that in the equation here, we have a minus sign, right? But when we go to highlight the vertex, we only have h instead of minus h. So that just means that whatever is in the equation, we take the negative of h. Okay, so keep that in mind. So what do they represent? So h represents how far left. So it's a horizontal shift. Pardon the writing. And basically, how far left or right the graph moves, shifts along the x-axis. So if we're going left or right, we're moving in direction of the x-axis. K, on the other hand, represents a vertical shift. All right, so how far up or down the graph shifts in the direction of y, in the direction of the y-axis. So that's what h and k tells us. All right, so that's the first part. Then, if I look at, so keep in mind what this equation looks like. And actually, I'll just rewrite it real quick so we know we have y equals a times x minus h squared plus k. So let's look at a. What do we get from a? A is what we call a compression slash stretch factor. A is a compression or stretch factor. So if A is a proper fraction, then the graph is what we call a vertical compression. If A is a proper fraction, the graph has a vertical compression or horizontal stretch. Okay, this just means that it's pressed against the x-axis. Right? If A is a proper fraction, the graph is either compressed vertically, so we're like pressing it down towards the x-axis, or it's a horizontal stretch where we're pulling it far apart in the direction of x, or away from the y-axis, I should say. If A is bigger than 1, then the graph has a vertical stretch or a horizontal compression. Okay, so a vertical stretch means that you're pulling it in the direction of y, or you're squeezing it against the y-axis. So that's what that means. And then the last thing is that the sign in front of A. So there could be a sign right here. Okay, in this case it's positive, but if the sign is negative, in front of A, then that means the graph opens downward. Okay, so the arms are facing downward. And what does that mean? That means there is a max value at the vertex. When we say max value, like y, that's the biggest y is going to get. So the opposite is also true. If it's positive, if there's no negative sign, so if positive, the graph opens upwards. And we have a minimum value at the vertex. So y can only be that small. All right. So the next most important thing to note is that all transformations are based on what happens to y equals x squared. So let me put that on a graph real quick. Y equals x squared. All right, so I have 1, 2, 3, 5, 6, 7, 8, 9. I have 1, 2, 3, and I have 1, 2, 3. So I know that if I could build this from a table of values, I'll do that actually. So I'm going to start with -3, -2, -1, 0, 1, 2, and 3. So when x is -3, if I plug -3 into this equation, I get -3 squared, which is 9. So this is going to be 9. Do that for -2, I get 4. I get 1, 0, 1, 4, and 9. Then I could graph these. So this is 1, 2, 3, -1, -2, -3. And then my first point is at 0, 0. I have a point at 1 and 1 and -1 and 1. I have a point at 2 and 4 and -2 and 4. I have a point at 3 and 9 and -3 and 9. And then this is, even though it's a terrible graph, this is my equation, y equals x squared. So all of these transformations that are happening, y equals a times x minus h squared plus k. Okay, so we're really starting with this graph, and we're going to first shift the vertex, and if the vertex shifts, all the other points have to follow. So what I'm doing with the vertex, h tells me to go either in the direction of x, some value. This is h, right? If I have x minus, then I'm going to go in the positive direction. Okay, I'm going to come in this direction. So this is where this goes right if negative. All right, and then I'm going to go left this way if it's positive. So if I have x plus 2, that means I go -2 to the left. If I have x minus 2, and I mean in the brackets, then I go +2 to the right. Okay. Now k, on the other hand, k just tells me that I'm going up and down along the vertical axis. That's all it is. So if I have a plus k, that means I go upwards. So plus k, my new point is here. If I have a minus k, then I simply go downwards. So I'm shifting the vertex. All right. And then if I have a plus a, then the graph opens up. If I have a minus a, the graph gets flipped. So in this case, it might look something like this. If it's a minus a, or if it's, sorry, not even a minus a, if it's just a minus. A tells me how it behaves along, if it gets squeezed or compressed or stretched. So if a is a fraction, is a proper fraction, okay? So if a is less than 1 or bigger than -1, then it's going to get stretched out like this or like that. Okay? If a is greater than 1 or a is less than -1, then it's going to get squeezed against the y-axis. Okay, so that's what that means. All right, so let's discuss some examples. I have a few examples to go through, and let's get started. So example 1. Suppose you have y is equal to 1/2 x minus 1 squared plus 5. So our vertex, remember it's a coordinate, equals to h and k. And in this case, it's going to be 1 and 5. Remember, we take the negative of whatever we have in the bracket. So I have a -1, so I'm going to get 1. So my vertex is at 1 and 5. What does this mean? H equals 1 means I go 1 unit to the right. K equals 5 means I go 5 units upward. So the graph has shifted 5 units upward. Okay. The equation of the axis of symmetry, AOS, is just x equals h. So h is 1, so that's the equation of the axis of symmetry. And the axis of symmetry, if I have a parabola, the axis of symmetry is what cuts the equation in half. Okay? So half is over here, the other half is over there. All right. And then in this case, I know if I look at the 1/2, or before I look at the 1/2, I see that the sign in front is positive, so the graph opens upward or upwards. But then I see the 1/2, and the 1/2 is a proper fraction, so the graph it's a vertical compression or horizontal stretch, whatever you want to call it. Horizontal stretch. Okay? And then the other question I could ask myself is, does it have zeros? Does it have roots? Are there roots? And the answer is no, because the minimum value is 5, which 5 is above the above the x-axis. 5 is above the x-axis. Okay, so to have roots, remember the equation, the graph, so the arms of the equation or of the graph needs to pass through the x-axis. In this case, it will not pass through the x-axis. All right, next example. So if I have y equals -3 times x plus 4 squared minus 6. So I'm going to look for my vertex, which is h and k, and that's going to be -4, -6. Okay, so what do I have? I have a horizontal shift left by 4 units. 4 units to the left. I have a downward shift, or a vertical shift. Maybe I should write this consistent. So I have a vertical shift, and that's downward by 6 units. Okay. I see that there's a negative sign in front, so the graph opens downwards. And right away that tells me there's a max value at the vertex. And that's going to be where y is equal to -6. All right? And then the next thing I'm going to look at is the equation of the axis of symmetry, which is x equals h. And this is, in this case, x is equal to -4. So that splits the graph in half. And then the other thing that I'm going to talk about is the 3, the factor of 3. So this is a vertical stretch or horizontal compression by 3, by a factor of 3. This by a factor of 3. And that's that. Oh yeah, and before we go, are there any zeros? Are there any zeros? No. The max value, can you even read this? My apologies. Max is -6. That means that because the max is -6, it doesn't go higher than that. So it doesn't even come near the x-axis. So it doesn't have any zeros. None of the arms pass through the x-axis. Okay, one more. Y is equal to 7/2 times x minus 1 squared plus or minus 2. Okay, so our vertex xy is equal to hk is going to be 1, -2. All right, so our axis of symmetry is going to be x is equal to 1. Okay, so the graph is going to be equal on either side at 1. So what else do we have? We have h, we know is 1. So that means we have a horizontal shift right by 1 unit. We have a vertical shift down by 2 units. All right. We have a minimum value because the sign in front is positive. And that also tells me that the graph opens upward. Okay. Now the 7/2 is bigger than 1. So we have a vertical stretch or a horizontal compression by a factor of 3.5 or 7/2. Okay, and do we have zeros? Yes, because the minimum value is -2. All right, so it's going to drop all the way down to -2, and as it goes up towards infinity on either arm, it's going to pass through the x-axis. Is -2. and the arms cross the x-axis. Excellent. So that's important to know. All right, so now let's get into some examples. So the first example that we want to do is we're going to determine the equation in vertex form, and by this we mean quadratic equation, in vertex form with a vertex of -2, -2, and a factor of -2/3. All right, so this is pretty straightforward. So if my vertex is given as, remember we have x minus y, x and y is equal to h and k, right? So in this case, the vertex is -2, -2. So my equation right away becomes, and if I write out my equation in vertex form, I have y equals a times x minus h squared plus k. So if I sub in my values, I'm going to have y is equal to a times x, and I have -2, so we always take the negative, so it's going to be x plus 2 squared, and then k we keep as is, -2. But we're missing a. How do we get a? Well, it says the factor, so that's given. So it just really becomes y is equal to -2/3 times x plus 2 squared minus 2. Okay? So now we could, comment on this about the fact that there's a negative sign, so it opens downwards. We have 2/3, which is less than 1, so it's compressed towards the x-axis. So that is a horizontal stretch and a vertical compression. It's shifted over to the left by a factor of 2 units, and then it's shifted down by a factor of 2 units. Maybe those aren't factors, but just 2 units in either direction. 2 units left, 2 units down. Okay. Next, we're going to find the equation given the vertex is -3, 4, and the point -4 and 5 is on the curve. Okay, so the first thing we're going to do with this one, write out the equation in vertex form. So the equation is y is equal to a times x minus h squared plus k. That's the equation. Then you're going to take the information that you have, and you're going to plug it in and then see what's left. So I'm already given the vertex. So I'm going to put that in there. So I have y is equal to a times x minus 8. So because this is a minus sign, I'm obviously going to take the opposite, which is plus 3. We'll square it, and then plus 4. So we keep k as it is. We're missing a. So in order to find a, all you need is a point on the curve. So let me just write that down. To find a, you need the vertex values and any point on the curve. And in this case, we're given -4 and 5. So we're going to plug that into the equation. So what we have is 5 is equal to a times -4 plus 3 squared plus 4. You see, we're solving for a. It's the only thing missing. So we're going to work through all those values. So I have 5 is equal to a times -4 plus 3 is -1. So I have 5 is equal to -1 squared is 1. So I have a plus 4 So A is just going to be equal to 5 minus 4. A is equal to 1. All right? So because A is equal to 1, my equation simply becomes y is equal to x plus 3 squared plus 4. You cannot make the assumption that A is going to be 1. You have to actually solve it. Because really and truly, A could have been negative 1. And if there was a negative 1, then my equation would become y equals negative x plus 3 squared plus 4. And we know this sign changes the whole thing. It turns it upward. So you have to solve to make sure that you get a value for A so that it tells you not only the compression slash stretch factor, but it tells you if it's flipped along the x-axis as well. Okay. All right, so what if we're given a graph and they tell us to find the equation? So let me draw a graph real quick. And then we're going to work our way backwards. So right, so I'm just really hitting the main points here because I'm a little bit lazy. And I hope it's nice and it behaves well. So I have, it's not going to behave well, I can already tell. Okay, doesn't look too bad. So it still looks like a parabola. All right, so let's find the equation. So what do we have? We have the vertex. This is, so the graph is split on 1, right? So our vertex is going to be negative, not negative, start with the x value. Our vertex is going to be 1, negative 4. Great, so let's plug that in. Let's start with our equation first, and then let's fill in what we have, and then we'll solve for the rest. So I have the vertex, so I have a times x. So x, it's positive 1, so I'm going to write minus 1 squared, and then k is at negative 4. So I'm going to write it as it is, minus 4. Okay, so now to find a, I just need any point, and I have lots of choices. I could take this, I can take this, and I can take this. I want to take the point that has the least amount of work. And I don't know what that is, but when I see a 0 in the equation, I can work with zeros. Zeros are fun to work with. So I'm going to actually pick this point. So that's negative 1 and 0. So that's what I'm going to use. So I have y is 0, x is negative 1. So I have negative 1 minus 1 squared minus 4. So I have 0 equals negative 1 minus 1 is going to be a times negative 2 squared minus 4. So negative 2 squared is going to be 4. So I have 0 is equal to 4a minus 4. And then, so now to solve for a, I have 4a equals 4. And divide both sides by 4, I get a is equal to 1. All right? So my equation just becomes y is equal to x minus 1 squared minus 4. Okay, so all that really happens here is that we have y equals x squared, and we move it 1 to the left and down 4, or 1 to the right and down 4. Okay, and remember what I said, you always have to solve for a, because you never know if you're going to end up with a negative value or not. Now we know we're not going to end up with a negative value because the graph is pointing upwards. We know that. But we also want to check if there's, what if it wasn't 1? What if it was 0.9 or 0.8? Okay, then it'll be it'll start stretching horizontally or get pressed towards the x-axis. So very important. Okay, now we're going to work our way to graphing. So what if you're given an equation, and they say, and they give you the equation in vertex form. So we have y equals x minus 2 squared minus 3. And they say, yeah, graph this, but don't use a table of values. Okay, so how do you do this? Well, the first thing that we need to grab, let's grab the vertex, h and k. So we know that the vertex is going to be 2 and negative 3. Okay, so we're going to graph that. The next thing you need to figure out is what we call steps. So the steps are pretty straightforward. And the steps start with a, and it's going to be 3 times a, 5 times a, 7 times a, and so forth. Okay, you don't need a whole ton of value, you just need some. So in this case, the value in front of the equation right here, it's not a 0, there's a 1 here. So in this case, a is 1. Then for the next step, it's going to be 3 times 1, which is 3. Then for the next step, it will be 5 times 1, which is 5. And for the next step, it's going to be 7 times 1, which is 7. And we'll show you how this works on the graph in a second. So if I go to a graph, the first thing I'm going to do is locate the vertex. Okay, so my vertex is at 2, negative 3. So I need to accommodate that. So let's go 1, 2, 3. So negative 3. I need a positive 2. Again, it's not going to look pretty because it's not nice and scale. So my vertex is at 2, negative 3. So it's sitting right here. That's my vertex. Maybe I should make it. Let's make it red. That's my vertex. Okay. So I also know that my axis of symmetry, right? So this is h and this is k. My axis of symmetry is, I'm going to write it down here. My AOS is x equals to 2. Right? So my axis of symmetry sits on this line. That's important because I know my graph is split, or my parabola is split in half at the axis of symmetry. So, how do I use these steps? Well, starting at the beginning, I'm going to go 1 unit right, and I'm going to go up in the direction of A. Okay? So I'm going to go 1 unit right, and I'm going to go up 1. So my next value is going to be here. I'm also going to do that on the left. So I'm going to go 1 unit left, and go up 1. Cool. Then starting here, I'm going to use my next value. So starting here, I'm going to go 1 unit left, but this time I'm going up 3. Okay? So I'm going to start from here, and I'm going to go up 3. So I'm going to go 1 unit left, and then up 3. 1, 2, 3. And then starting here, I'm going to go 1 unit left, then go up 3. 1, 2, 3. Okay, and if I have enough room on the graph, I'm going to start here. I'm going to go 1 unit left. 5. Put a negative 1 there. 1 unit to the right, and I'm going to go up 5. 1, 2, 3, 4, 5. I'm going to do the same on this side. 1 unit left and go 1, 2, 3, 4. Okay, wait, I messed up there. So this point here was a little bit high and therefore misleading. So I'm going to go 1 unit right and up 3. So up, right? 1, 2, 3. Yeah, it's supposed to be about here. That looks a little bit better. And then the next time I'm going to go 1 unit right and then up 5. So 1, 2, 3, 4, 5. Right about there. I'm going to go to the left, and 1, 2, 3, 4, 5. Yes. So it's okay to make mistakes with these. And then I connect the dots. Okay, and this is my graph. Y is equal to x minus 2 squared minus 3. So my vertex is here, and it's positive. So it's upward sloping, or it's not upward sloping, but it's going upwards. I have a minimum right here. Everything makes sense. Okay, let's do one more. So what do we have? We have y is equal to negative 3x plus 4 squared plus 5. So when I examine this equation, I already know some things. Negative sign, it's going to be opening downwards. 3, it's going to be compressed towards the y-axis. And then the other stuff I could fill in. So right off the bat, my vertex sits at negative 4 and 5. My axis of symmetry is at negative 4. Okay, great. So, and then the next thing I want to do, I want to build out my steps. So A is equal to negative 3. 3A is equal to, and again, I don't need a ton of these. It's going to be 3 times negative 3, which is negative 9. 5A is going to be 5 times negative 3, which is negative 15. And then 7A is going to be 7 times negative 3, which is negative 21. So you notice that these values here are getting smaller and smaller, which makes sense because it matches what I got from this, that the graph is downward sloping. Not downward sloping, it opens downwards. So let's come up with our graph and start doing some work here. So I know that I'm starting at positive 5. So I want more room on the bottom of my graph than I want on the top. Y, x, so I have positive 5 there. 1, 2, 3, 4. Okay, that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just doing enough to like accommodate for the 9. I might not need the 15, but we'll see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so first thing, locate the vertex. Negative 1, negative 2, negative 3, negative 4, and 5. So the vertex is here. I'm going to make that, let's make it blue. That's my vertex, right? Negative 4 and 5. So everything now is going downwards. Negative 5, negative 6. So we'll see. I'll label these as I need to. I normally don't like labeling them if I don't need to. Actually, let me highlight the axis of symmetry. So, boom, that's going to be all the way down there. Normally you draw it as a dotted line, but yeah, just to not get it confusing. Let me just draw it as a dotted line. Okay, perfect. So now I'm going to use my steps. So I'm going to take one step to the right, and A says go down to negative, go down 3. So if the sign is negative, I go down. If the sign is positive, I go up. So if I take one step to the right, it's going to take me to negative 3, and I'm going to go down 3. So 1, 2, 3. So that's my next point. And if I do that on the other side, it's going to also take me to here. Great. My next point is, it says go down 9. So if I take one step to the right, I got to go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I do the same thing. One step to the left, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. And then now I do my best to connect the dots. Yes. Now, I did say like it gets squeezed towards the y-axis. It doesn't necessarily mean like it's not always around the y-axis, but it does get compressed in the direction of y, right? In this case, it's a little tighter than if it was just y equals x squared. Okay, that's it for that.